Hi, this is Zach Semke with Passive House Accelerator, and thanks for tuning in to this special bonus episode of the Passive House podcast, recorded at Passive House Network's 2023 conference in Denver, Colorado. And a big thank you to EnerSign for the support of the series. The interview you're about to hear was hosted by Ilka Cassidy, co-host of the Passive House podcast.
This is Ilka Cassidy with the Passive House Accelerator, and we are in Denver at the Passive House Network Conference, and I'm here with Lois. Thanks for talking to me.
Sure. Thank you.
Could you just quickly introduce yourself and tell us what you do?
Sure. I'm the Director of Passive House Services at Stephen Winter Associates. I have a whole team dedicated to Passive House design and consulting and verification, and we focus mainly on large-scale complex projects, and first of their kind type of Passive House projects, like Corner Shell Office Space that we just got certified, and we did a hotel recently that we just got certified. So very exciting stuff from our staff.
Yeah. And I just attended your very excellent session.
Thank you.
And it was all about multifamily data collecting and monitoring.
Yes.
Which I think is so important, because what we do as Passive House consultants is so much about modeling and basically looking at what the Passive House standard assumes for modeling, but it doesn't necessarily really say what the buildings do in real life.
Right.
So what's so important is to actually go back and double check how these buildings are actually performing. So how do you see the relationship between the modeling and the monitoring?
So generally speaking, the modeling comes in under what the actual performance is. So our site UIs and actual performance are higher than the model. And I know people get nervous about that, and like, how do we create programs and depend on that data, on the model data. But honestly, we've been able to narrow it down to probably a couple of different areas that make an extreme difference and bring that model. We use those assumptions. They bring the model data much more into compliance with the actual. And one of those things is our assumptions in the modeling for domestic hot water use. And so what we found is the European assumption for domestic hot water use is probably half of what the North American multifamily occupants use, and that's pretty standard. Mm-hmm. And what we're finding is that these values are pretty consistent with what the DOE says North American values are. So I think it should be very comforting. Because once you add that into the model, you consume that model, you kind of come within, like, I would say between 10 and 20%, which is a really good number for predicted models, Yeah. And then the other place that I've heard, and I've read other people's studies, is that we think we're missing something. We're not assuming something high enough in the common area usage. So we're not quite sure what it is. It could be elevator usage, and it could be booster pump usage, because in any of our buildings that are over 6 stories, we have domestic water, the cold water, booster pumps to get them up to the taller buildings, at the higher floors. And so we think the culprit's in there somewhere, and we need to sort of sub-meter those uses to see. And I just don't have anything in the works on that yet, but I keep trying.
Yeah. So the very important point, though, just to understand, is if you model or use the modeling software and model towards certification, that's different than actually modeling towards actual usage.
And I think what practitioners need to understand is if they're trying to do a utility analysis for their client, they just need to use the more accurate American assumptions to provide that analysis. But for certification, we use the certification assumptions, right? Yeah. So the certification is not what's actual.
Yeah. And then you talked about difficulties actually getting the data from the monitoring. So what holds us back to actually get this data? That is so important.
So firstly, we usually suggest monitoring. Unfortunately, it usually gets VE'd out. So our incentive programs aren't in sync with when that money needs to be delivered. Our incentive programs for monitoring happen after the building is constructed. Then you can get incentives for monitoring. But they need it at the beginning so that they can design it in, pay for it, and get the contractor installed. Right? It's so much cheaper if you do that than if you try and do it after the fact. So that's one of the problems. So we don't have a lot of actual monitoring in the buildings. What we're using is utility data. So we're taking it from Con Ed, from the owners that are monitoring their own buildings at the meter level. So it's not at the individual, like the ERV or the elevator or the VRF system. So it's whole building data. And then you're trying to make assumptions on what part of that is heating and what part of that is cooling. So it's a little.
Yeah, I mean, it should be a requirement, right, to itemize out.
It should be, but they're already so strapped on their budgets. It's hard to enforce that on a typology that is so needed and is so financially strapped already. So what they require has to be, kind of, what do I want to say, balanced with what is actually needed.
Yeah, but I mean, it's just, again, so important to do the monitoring because it really informs what is not working right in the building.
Yes.
Because a lot of things can happen. You talked a lot about actually the servicing of filters, for example, and I would like to hear a little bit more about that. But then there's also so much information that we can use just to learn from, right? And also that put feedback into our energy models in the first place so that we can actually more accurately predict everything, right?
Yeah. The good news is that as we get more and more data and our developers do more and more projects, they just keep doing more and more. When we show them the data, they get more interested in knowing what it is. And they're starting voluntarily to put monitoring in their projects, which is great.
Yeah.
So we're at that point where we're getting more buildings online that actually do have some end use monitoring. So I think that's going to really inform the next round of analysis.
Yeah, and this is actually something I'm really curious about as well. Like once you do, and it goes with both the modeling and monitoring, it seems that sometimes clients can be easily or believe you a little bit more when you have data or numbers to show them.
Absolutely.
So do you find that you use your monitoring or modeling to communicate with clients or team members, or how do you use those results?
So usually what I find is the most useful, or the contractor that finds it the most useful is the mechanical engineer. Because if we can show them that their peaks are way lower than what they're calculating to size their equipment, then they'll come down. And especially if it's on the same developer's other building. And we're like, look, this is his building. This is Passive House. This is what the data says. You're doing the exact same thing. Make this smaller. And it's hugely impactful on something like geothermal, where those wells are so costly. And so if they can reduce the wells, they save a lot of money. So the MEPs, they're so worried about risk that they oversize normally. It's just the inherent industry. So when we can show them, no, you don't have to, and they don't have to worry about lawsuits, and I can't get enough heating, I can't get enough cooling, and they're okay, right? They relax, and then they start to work with what the data we have. So it's been very impactful in that area.
Yeah. And then, as I mentioned, you talked about like the servicing of the equipment. What is your take on that?
So not was in respect to individual ERVs that are inside an apartment versus central ones that are in the roof. And so the difference is these large pieces of equipment generally have a service contract associated with them, where the small don't. It's the building super that has to take care of the individual ones. So you have a service contract, somebody's coming at least twice a year to service that equipment, change your filters. And it's easily accessible. The little ones, you got to get in when someone's there. Some people will not enter an apartment unless somebody's there to let them in. So, and those filters have to be changed at least twice a year, same as the central ones. But they also have to be maintained from the outside to clean the grills. And we're finding that that's not happening. Time after time after time, they go into an individual unit. Often it's shut off because the tenant thinks it's costing them money. And then we pull out the filters first thing, and they're always dirty. I have not been in one apartment that has run for at least 6 months where the filters are dirty.
Yeah. So that would speak towards actually doing indoor air quality monitoring as well, correct?
And when that happens, when the filters get clogged, right, you're only getting an exhaust-only system at that point, because most of that clog is on the supply side. Right? It's pulling the dirt from the side. So you're getting an exhaust-only system, and you're also throwing the fan power up. So the fan power is going to climb from, say, 0.76 watts per CFM or 120 watts. It said 120. So we saw one in one of our first pass fails go to 240 watts. And the woman was like, there's a loud whistling over my door. What is happening? So we went up to check on the system. The intake on the outside was all clogged, so they weren't getting any supply air. So it was acting in exhaust-only mode, so it was depressurizing the house. So it was sucking air in over the door, like one of the only cracks in the house.
Yeah.
And that's what was happening. And the watts went from 120 to 240 on that unit. And we were actually monitoring that system under Department of Energy program, and we could see in real time what was happening from our offices. And we're like, oh, what's happening with this fan energy? So, yeah, so it speaks to indoor air quality, energy use, comfort, acoustic comfort.
Yeah. So that's interesting, though, because at the end, you would think putting in monitoring systems from the beginning and accounting for it actually saves you money, right? Because you're able to see when something is not really working right. You don't have to go through every apartment to double check, because it's really, really difficult to actually get into each apartment. Right?
Well, so that's the thing. It's on the meter of the apartment. The tenant is paying for those individual ones, not the building owner. Yeah. It was the same with the one I just told you. That was actually a single family house.
Okay.
So they were responsible for cleaning their own filters. But they didn't know. It's the first time in their life they lived with an ERV. They didn't know the outside could get clogged. Yeah. But yes, it would save the homeowner money.
Yeah.
But it takes so much education.
Yeah. So anything else that you would like to share? Any kind of findings or feedback?
I think the data we're getting, at least from a whole site EUI, is very encouraging and is going to help the lenders, the funding agencies comfortably invest in passive house buildings. They'll be like, oh, okay, as long as they go through all of the QA, QC, whether they make it or not to the finish line, as long as they go through that whole process, they're actually going to perform very well. Because even the ones that miss the blower door by a little, or ventilation's off by a little, and they can't get that certificate, they're still an excellent building, and it's going to perform just as if they did. So it's really the QA, QC process that gives you a passive house. And so any lender that wants to give a reduced interest rate or whatever would really want to ensure that they're requiring that whole process get done.
Yeah, because you can design whatever you want.
Exactly.
If it's not executed right, or serviced right, then it's not going to perform the way predicted. Yeah. Thank you so much.
You're welcome.
And enjoy the rest of the conference.
Thank you.